The pitot system drives the airspeed indicator, altimeter, and vertical speed indicator. As a pilot, it's important to understand how this system works. Our discussion of the pitot instruments will begin with the airspeed indicator and three different types of airspeed: indicated, calibrated, and true.
The airspeed indicator is an extremely sensitive differential pressure gauge. It measures the difference between impact pressure measured at the pitot tube and static pressure sampled by the static source, which is the undisturbed atmospheric pressure. When the airplane moves through the air, the pitot pressure is greater than static pressure. The difference in pressure is indicated by the airspeed indicator. There are three kinds of airspeed with which you should be familiar. First, indicated airspeed is the airspeed read directly from the indicator, uncorrected for instrument error, installation error, or differences in atmospheric density. Next, calibrated airspeed is indicated airspeed corrected for errors of the indicator itself and errors caused by the position of the pitot and the static source. With certain flap settings and airspeed, these errors may be significant. At normal cruise speeds, there is usually very little difference between indicated and calibrated airspeed. The pilot's operating handbook will have either a calibration table or a graph. For the 172, when the indicated airspeed is 100 knots, the calibrated speed with flaps up is 98 knots. To use this calibration graph, enter, for example, the indicated airspeed of 120 knots. Then go up to the flaps up line and across to the calibrated scale and read a calibrated airspeed of 117 knots. The third type of airspeed is true airspeed, which corrects calibrated airspeed for variations in air density. The airspeed indicator shows true airspeed only at sea level on a standard day. As altitude increases, the air density decreases and the ram or impact pressure in the airspeed indicator decreases. With the same power setting, indicated airspeed decreases as altitude is increased. As a rule of thumb, true airspeed increases over calibrated airspeed at the rate of 2% per 1,000 feet of altitude. Using this figure, at 6,000 feet, if the calibrated airspeed is 100 knots, the true airspeed should be 112 knots. The more accurate calculator solution will be covered later. In Volume 1, we told you the airspeed indicator has color markings which are specific to the airplane make and model. The green arc shows the normal operating range. The low airspeed end of the green arc indicates the stalling speed, power off, flaps up, at maximum certificated weight. The upper limit of the green arc is the maximum structural cruising speed. The yellow arc represents speeds that should only be flown in smooth air. The red radial line marks the never exceed speed. The white arc is the full flap operating range, with the upper limit the maximum speed for full flaps extended. The lower limit is the power off stalling speed at maximum certificated landing weight with flaps extended. The color markings may be in indicated or calibrated speeds. Generally, newer airplanes have the airspeed indicator color marking in indicated airspeed. Be sure to check the pilot's operating handbook for the airplane you're flying to determine whether the color marking is in indicated or calibrated airspeed.
An important speed that is not marked is the maneuvering speed we told you about earlier. If rough air or turbulence is encountered, the airplane should be slowed to maneuvering speed or slower to minimize the stress on the airplane. Maneuvering speed is not marked because it changes depending upon the weight of the airplane. The pilot's operating handbook lists the maneuvering speeds for different weights.